Another question on clipper is parallel clipper circuit. Here the diode will be connected in parallel to the input voltage. So this is the question. You have a parallel clipper circuit and with this is the input is triangle voltage from 0 to 16 volt peak. That is the input voltage. So let's solve this problem. So our first step, as I told you, step 1, you need to find the voltage where the diode will change its state from on to off or from off to on. So that on from off to on, that position, you understand that the diode is just going to be on. So your VD will be equal to 0. Considering that I am taking this diode as an ideal one. I am considering this diode to be an ideal one. So VD will be equal to 0. And then the current is not yet started flowing, so IR is also equal to 0. So just apply your KVL as the normal manner. So this is current flow like this, so this is plus, this is minus. So this is the current IR into R, that is the voltage drop across this VR. So the diodes minus here, plus here. The diode is placed in such a way that negative comes to connect to the positive part of the supply voltage. So now look at this. I'll apply KVL. So minus to plus, plus VI. Plus to minus, minus IR multiplied by R. That is the voltage drop across the resistor. Minus to plus, plus VD. Plus to minus, minus 4 volt should be equal to 0. So this is equal to 0. This is also equal to 0. So what is this? VI minus 4 equal to 0, or your VI should be equal to 4. So this is the voltage, changing input voltage that changed the diode state. So now we need to find whether Vi greater than 4 or whether Vi less than 4, your diode is on. So look at here, the diode is placed. The diode is placed in negative, up is connected to the positive. So obviously for the positive half cycle of the voltage, this diode, positive to negative diode should be off. So we can consider it as Vi greater than 4, that is the positive, all positive will come, Vi greater than 4 volt. We can consider it that point diode should be off because negative to positive will come. So diode is off. So obviously the other case, Vi less than 4 volt, your diode should be on. Your diode should be on. Now go to the step 3. Step 3, we are going to consider the first case as diode off. When the diode is off, what is the condition? Vi greater than 4 volt. So the diode is off is a consideration that Vi greater than 4. The output voltage, we need to apply KVL like this. So as we know that now your circuit is something, diode is going to be off. So it's like this. This is your input voltage Vi. This is going to be your input voltage Vi. So you're taking your output across this, and we know that there is no current here. So output voltage means it is just directly like, output voltage is just directly like the voltage what is applied to the input voltage Vi will be appearing across the output. So V outputs should be equal to V input, because you know that when you apply KVL, Vi minus to plus, it is Vi. So like plus to minus, minus VR minus V out should be equal to 0. And you know VR equal to 0 because there is no current, right? So IR is current, as diode is open, IR is equal to 0, there is no current, VR is equal to 0. So what is your V input? V output should be equal to V input. So whatever be the output, that will be coming as the input. Whatever be the output, that will be coming as the input. So that is about your diode off condition. So the next is diode on condition. So when diode is on, what will happen? Your Vi is less than 4 volt. Your Vi will be less than 4 volt. This is the condition that diode is on. So if diode is on, you apply KVL. So what will happen? Your output, or even you can apply KVL in this direction also, because diode is on. So this is your output is here, right? You are taking your output here. This is minus, you are taking your output here. So diode is on. Diode is on as you are taking it as an ideal diode. So diode on means what is VD? VD will be equal to 0. So apply KVL in this direction. So this is minus, this is plus, and this is 4 volt. So when you apply KVL here, so how much you are getting? Minus to plus, plus 4. Plus to minus, minus VD. Plus to minus, minus V out should be equal to 0. And VD is 0, we know, right? When it is on, VD will be equal to 0. Diode is on, VD will be equal to 0. So 4 should be equal to your V out. So when the diode is on, your output voltage is a constant voltage of 4 volt you will be getting. The output voltage you will be getting as a constant 4 voltage. So now we can go to the drawings. So now we have two conditions over here. First is the 4 volt case, right? So above 4 and below 4 we are considering. So when it is, this is suppose 4 volt. So when it is 4 volt, above 4 diode is off. Above 4 diode is off, and what you will get? You will get exactly your V input. Above 4 diode is off, and you are going to get your V input as your output, because V input is greater than 4 volt. Your diode is off and your V output should be equal to V input. Similarly, when V is less than 4 volt, your diode is on and your V output is equal to 4 volt. That already we derived in step 3 and step 4. So now this is up to here, it is 4 volt. Above that, it is exactly same as your input voltage. And below 4, up to here, maybe like up to here, again you can take it as the 4 volt because diode is off. So this is going to be your output for the parallel clipper circuit for the given question. One more example problem we are discussing on parallel clipper. So here you see that diode is keeping on reverse direction. Diode we are keeping on the reverse directions, and polarity also reversed in this example. And we are using here a silicon diode instead of a normal ideal diode. And you know that silicon diode, your VD will be equal to how much? When it is on, it is equal to 0.7 volt is the cut-in voltage. So your first step is same manner we are proceeding. As a first step, you need to find at what point of input voltage your diode will change state from off to on. So just apply your KVL in the normal manner. So minus to plus, plus VI, minus. The step 1, consider that VD equal to 0.7 and IR is equal to 0. Current is not yet started, but diode is just on. So VI minus, so this voltage like this you are assuming, so this is plus to minus, take it as VR. So IR equal to 0 implies that VR is also equal to 0. So minus VR plus to minus, minus VD and minus to plus. So this is minus to plus. So plus 4 should be equal to 0. So it is VI minus 0 minus 0.7 because you are using a silicon diode, plus 4 should be equal to 0. So you know we're getting as VI is equal to minus 3.3 volt. Minus 3.3 volt. That is the input to voltage point where your output will going to be changed. So minus 3.3 volt will be somewhere ever here will come. So that is step 1. Now what is our step 2? In step 2, we need to look when diode will be on and when diode will be off. Is it VI greater than this voltage diode is on or off? So diode's positive is connected here. Of course, positive half cycle part diode will be on. So we can say that when Vi is greater than minus 3.3 volt, your diode will be on. Similarly, when Vi is less than minus 3.3 volt, your diode will be off. So that is also now clear. Now next is step 3. So in step 3, we need to apply the KVL. In step 3, now consider the case as diode on. So when diode is on, what is the condition? Diode is on, Vi is greater than minus 3.3 volt. Vi is greater than minus 3.3 volt. So here, now when we apply the KVL, so our output voltage is something like this. Here is your output taking, right? Diode is on. So it is a silicon diode, so 0.7 volt it is on, and this is supposed to be 4 volt. So now apply KVL in this direction. So plus to minus, so it will become minus 4, minus to plus 0.7, minus V out should be equal to 0. So what is your V out? V out should be equal to minus 3.3 volt. So that is a fixed voltage minus 3.3 volt. You are going to get it as the V output when diode is on. Now when diode is off, so when diode is off, what you will be getting as a step 4? Now diode is off. Diode is off means what is the condition? Vi is less than minus 3.3 volt. So when diode is off, it is just like an open circuit. So how is your circuit? It is just like an open circuit. You are applying here your input voltage and you are taking output voltage here, but that line is open. Okay, so you know that when it is open circuit, so diode is an open circuit. What is the current? I diode or IR will be equal to 0. So what is the voltage across the resistor R? Obviously VR should be equal to 0. So minus to plus VI minus VR minus V out should be equal to 0. So what is your V out? V output should be equal to Vi. Same Vi will commit as the V output for the voltage Vi less than minus 3.3 volt. So now we can draw your output. You can draw your output. So two conditions. First condition, diode on. So that means you have Vi greater than minus 3.3 volt. Diode on, your output will be equal to how many volt? Your output will be equal to minus 3.3 volt. And when Vi is less than minus 3.3 volt, your output will be equal to, it's a constant volt, no, same input voltage will come as the output voltage. So now this 3 point, we will mark the line minus 3 point, that is the border line. So we will mark that point as, this is minus, suppose this is going to be minus 3.3 volt. So now minus 3.3 volt, somewhere like this it will come here. So from minus 3.3 volt onwards, it is greater than minus 3.3 volt. So your output is a fixed voltage of up to here. The moment it becomes less than, then only the output voltage will change. Up to here, your output voltage is a fixed voltage of minus 3.3 volt. And after that, your output is same as that of your input. And again also same input. So that is minus 20 volt. Again it is same, like greater than 3.3 volt, it is same fixed minus 3.3 volt will be your output. So that is about the parallel clipper. So hope this, with these two problems, series and parallel problem, it's the concept of clipper is clear.